Welcome back to Out of the Blue. I'm Andrew Ottman, coming to you from the Applied Engineering Building, the latest addition to the campus of Middle Tennessee State University. And with me, Dr. Saeed Farudistan, Professor of Engineering Technology, and the guy that came up with the Experimental Vehicles program. Saeed, why did you do it?
Well, when I was getting my PhD in some place in Tennessee, Someplace in Tennessee, I thought I was the king of everything because I knew how to design on the computer, make everything on the computer. When I finished my PhD, I went to work for the industry. I realized, oh my God, I don't know that much because the thing I design on the computer, they are not manufacturable. So I went through the line, stayed with the worker, and I learned a lot from them. Then I went and sat down by my desk and I designed the things that is manufacturable. And I came up with a patent with it, and it was excellent. After a couple of years, I wanted to go back to the education. That was my heart was always. When I came to MTSU, I realized that a student, they don't know why they take statics, dynamics, they don't have hands-on experience, and I remember what happened to me. So I told them I want to create some hands-on. They said, do logo stuff. I said, no, I need to do something that a student can build, can design, and they can go national and international competition with. So they know how good they are, okay? And I require each of the EVP project, at least 80% of them is done by the students. They design, they build. They learn about hands-on experience, teamwork. The first time I put a team together, they were fighting with each other. You telling me what to do? I am better than you. No, it's teamwork because I let them make mistake. They learn from their mistake, and when we go to the competition, some big name school, they come in with something break, a student are standing like this, somebody come and fix it for them. Our student, when something break, I stay like this. A student make it because they already made it hands-on themselves, and we have won a lot of award, especially in the rover competition, because it is a student hands-on. And I see a student come to see me. Do you remember me 5 years ago, 10 years ago? I was in this EVP Experimental Vehicle program. Because of it, I got an excellent job. I learned and I use those things at the company I am working. I am moving up, and I am so happy to see them graduate and go to work. And when they go for a job interview, they will say, I work in this project. And people, especially Tennessean, they love racing. Oh, you did that? You did that? You built this? They get a job, they make more money. And then because of the experience they have, they can do excellent job at the company that they are working.
Well, let's see a couple of these vehicles. Let's start with the Baja. So we're here with Andrew Starkey, one of our student ambassadors for engineering technology, captain of the Baja team. So, hey, how do you start this thing?
So it's a pull start motor in the back, just like a lawnmower.
Yeah. What does this do versatility-wise? I mean, is it a rough ride? Is it a smooth ride? I mean, what is it supposed to do?
Well, it's supposed to go over a rough ride, but make it feel smooth.
Wow.
It's supposed to do a bit of both.
Wow. Saeed, why is this, how do you integrate this into learning? What are they trying to accomplish with this?
I require, as I said, 70% of this bid by a student. And when they make them, usually we take them to the high school. When the student coming in, we show them this, like Civil Air Patrol, they coming in, or Blackman Academic, they come in, we show them, they write this around. Oh, how can I build this? You major in engineering, you do the best you can, and everything gonna fall in place for you.
That's great.
And they because there's excitement they see. And this thing right here, it goes over the rock, on the water, and it flies. Sometimes you go up the hill,
Wow.
come down, it's about 4 feet above the ground.
Have you done that?
Oh, yeah.
You've done that?
Oh, yeah.
So you're a little bit of a thrill seeker,
Yeah,
right?
just a little.
Okay.
Yes,
All
and
right.
it's excitement for going on. And when we bring the high schoolers, middle schoolers here, they love to drive these, ride this. Okay, when I come to the school, what should I do? Come on down, join the club. Even if major is not engineering, we let you join the club because we are here for you to learn.
Andrew, did you build this thing?
I did not build this one personally. This one was before I came here, but this one is like one of our retired vehicles that did very well at competition.
So it's almost in the Hall of Fame.
Yes,
right?
sir.
Okay, well.
And he is building one by next 2 weeks.
Really? Fantastic.
Because October we are going competition.
Wonderful, wonderful. Okay, well, best of luck to you, Andrew. I think this is going to be great. What tips do you have for anybody that wants to learn how to drive one of these things?
I'd probably say just probably find the lead person in charge and go bother them as much as you can.
So, Andrew, thanks for the tour. Sahid, what's the next one we're going to see?
Next one is what they used to call moon buggy, but they changed the name now to rover, NASA rover.
Sahid, tell me about this. What is this?
This is used to call moon buggy, but they changed the name a couple of years ago to the NASA rover. It goes over the rock, over the half of the rover in the competition will break, you know, so they have to be good. And 3 years ago, they changed the rule. They said the tire we used to have, it was air in it. They said when we go to the moon, there is no air.
That's right.
So they told us it has to be airless. And our student did an excellent job. They came up with this 3D printing of designing the rover and building the wheels themselves like this. And they did a super job. We had won lots of awards in there. We are the second school in the number of awards that has been won, okay?
And Sahid, I want to be clear. When you say they, you're talking about the National Aeronautics and Space Administration, right? NASA, right?
NASA, yes.
Wow. Yeah, and then that's the competition we're in.
Yes, NASA. And then we are very famous over there when we go because we have won most of the award, and we have won Neil Armstrong Design Award twice. And because all of the hard work by the student, hands-on learning, and we won. Last year we did #1 in Tennessee and #12 in the whole world. Last year competition.
That's fantastic. So Andrew, what's it like to, I know you're the Baja captain. You've got to have some time and grade in this, right? What's it like to ride one of these?
It's just like a bike. Once you get used to it, it's pretty simple.
Yeah, easy to maneuver, easy to navigate?
Oh yeah. You got brakes in the back with the back driver and the front driver steers, and you're both pedaling. So it's a teamwork effort.
What about these tires? They work?
Oh yeah.
Yeah?
Oh yeah. The 3D printed allows it to actually have some cushion along with the suspension, so they kind of work both in together.
Wow. So Andrew, what's it like to get this kind of experience at MTSU where you're actually building things instead of just studying how to do things, you're actually doing things?
It's actually really good. It actually allows you to use school principles and then actually use it on a physical project. Because a lot of students don't have that physical aspect, and I mean, of course you can pass a certain number of classes, but can you actually do it in real life?
Andrew, Sahid, thank you for taking us on this tour of 2 of the great experimental vehicle programs. Sahid, thank you for developing this program.
And please, whoever sees this, we need to come to MTSU, join the program, and we will help you to be the next rider on the Baja.
That's right, we're recruiting now.